Hey everyone, today we are talking about the algorithm for subtracting integers. And basically the algorithm involves changing the subtraction into addition. So you change the subtraction symbol to a plus symbol, and then you change the sign of the second number. You make it the opposite. And we're going to look at kind of how this looks on the number line. So my first problem is 2 take away 5. I have a bigger number being subtracted from a smaller number, so I know my answer is going to be negative. Let's see what it looks like on the number line. So I have 2 take away 5. I start at 0. I go to the right 2 because it's a positive number. And when you subtract a positive number, you go to the left. It gets smaller. So then I'm going to go back 1, 2, 3, 4, 5. And it looks like it's at negative 3. So I went up to 2 and then had to go back 5 and get to negative 3. So looking at that as an addition problem, change my subtraction to addition. I changed the symbol, but I can't just change it to 2 plus 5. That's a completely different problem. It stays balanced. It stays the same if you change the operation and then you change the sign of this number. So instead of a positive 5, the opposite would be take away 5. Now look on the number line. If I was going to do this problem on the number line, it would look exactly like this. I would go up to 2, and then when I add a negative 5, I'd go back 3. And these two positive and negatives would cancel each other out. It's like having 2 black chips and 5 red chips. These black and red chips cancel each other out, leaving 3 red chips, or negative 3. So the sum of that is negative 3. So we had a positive taking away a positive. Now we have a negative taking away a positive. I'll do it on the number line. I start at 0. I go back 2 units. And then when I subtract a positive, remember, I keep going lower. That makes it lower. And then from there, I go 1, 2, 3, 4, 5. And it looks like I end at negative 7. I'm going to double check by changing this to an addition problem. I have negative 2. Change the subtraction to addition. Change the sign of the second number. So positive 5 becomes negative 5. And if I thought about this like using the chips, I have 2 red chips, plus I have 5 red chips. I have only red chips. Nothing cancels out. That's negative 7. And also my arrows keep going the same direction. I have negative 2, and then I go negative 5 more in the negative direction. And my sum is negative 7. I've got 2 more to do. The next one is 2 take away negative 5. Now I know this is remember when you're taking away a negative, you're making it bigger. Remember the video we watched last class where the guy had negative 2 cupcakes, but then that negative 2 cupcakes gets taken away and now he doesn't owe cupcakes anymore? Right? This is like being in debt $5, but then somebody takes that away. It's like somebody gave you $5. It's like adding 5. So if I were going to do this on the number line, I start at 0. I go to positive 2. And then subtraction usually means go left, but this guy says no, opposite. You do the opposite of it. So you're kind of like doing 2 opposites here, which brings you back to the thing. When we were talking about what is the opposite of down, it's up. What is the opposite of down? You're back to down, because the opposite of down is up and the opposite of that is down. So you're just kind of going back. Whoops. So I'm at 2, and I actually, instead of going left, this guy says do the opposite, go right, and I'm going to go up 1, 2, 3, 4, 5. And if we did the algorithm and we said, oh, let's change it to addition because that's easier, we'd keep the 2, we'd change the subtraction to addition, and make the second number have the opposite sign. The opposite of -5, +5. Now this looks like an easy problem. You look at that and you're like, that looks crazy. 2 plus 5, that looks easy. It's 7. And it looks exactly the same on the number line as when we did subtraction. You go to +2 and you keep going in a positive direction 5 more to 7. And one more. -2, take away -5. Okay, so I know I'm going to start on the number line by going down to -2. And then subtraction usually means go left, but this guy says, no, opposite. Go right, because when you take away a -5, you're making it bigger. You're taking away like $5 of debt, right? So you go up 1, 2, 3, 4, 5, and our answer should be +3. Let's see what happens when we change this to an addition problem. So I start with -2. I change my subtraction to addition, and I change the sign of the second number. So instead of -5, I do the opposite. I have +5. -2 plus 5, that would be like we went down 2, and then we canceled those 2 backwards and went 3 more than that to +3. Or if we were doing chips, we'd have 2 red chips, 5 black chips. 2 of those red chips would cancel out 2 of those black chips, and you'd be left with 3 black chips. So the algorithm for subtracting integers is just change the subtraction to addition. But you can't do only that, or else it completely changes the math problem. It's not the same thing anymore. It stays balanced. It stays meaning the same thing if you change the sign of the second number. Subtraction to addition, opposite for the second number. Make the second number opposite. And that is the trick for doing addition of integers.